Last week, I introduced the concept of using multiple reference frames in order to define the kinematics of a point on a mechanical system. One snafu when using multiple frames, though, is that there are times when you need to take the time derivative in terms of our fixed frame, which in this example here we'll call frame A, but those terms are written with respect to one of our moving frames. So for example, here we have a moving frame B or moving frame C. To resolve this, we introduce the magic formula. And this formula says that if you have a vector that's expressed in the unit vectors of a moving frame, so for example, frame B or frame C, you can take the time derivative of that vector in frame A by calculating the following. The time derivative of that vector, say vector V is written in terms of frame B, so you take the time derivative of that vector in frame B, plus you take the cross product between the angular velocity of frame B in frame A and the vector itself. In the problems you solved last week, you hopefully use this formula when solving for the velocity or acceleration of a point using multiple reference frames. This week, I'm going to introduce the super magic formula. And this formula is going to be very helpful when solving for the acceleration of a point when you're using multiple reference frames. And so in the remainder of the videos, I'm going to describe what the super magic formula is, how to derive it, and I'll go through some examples of how to use that to, again, make the calculation of acceleration a bit easier for you.